In this video, we're going to look at examples of finding the domain and range of several different relations. So we're asked to be able, in addition to be able to state the domain and range, we're asked to be able to determine whether or not the relation is a function. So in this first example, we have A as the set of ordered pairs 3, 1, 4, 1, and 5, 1. Remember, the domain of a relation is all the x coordinates that we see. So in this case, we see an x coordinate of 3, an x coordinate of 4, and an x coordinate of 5. So our domain in this case is the set containing 3, 4, 5. Our range is a set of y coordinates. In this case, we only see one y coordinate. We see 1 each time, so the range is the set containing 1. We note that this relation is a function because, notice, for the x coordinate of 3, there's only one y value associated with it. It's 1. For the x coordinate of 4, same thing. There's only one y coordinate. It's 1. For 5, there's only one y coordinate. It's 1. It does not say that the y coordinate has to change from x coordinate to x coordinate. It just says that for each x coordinate, there is only one y coordinate associated with it, which is exactly what it is. There's only one associated with each of these x coordinates. Maybe to make that a little bit more clear, let's look at the second example where we have B is the set of ordered pairs 1, 3, 1, 4, 1, 5. We've just flipped the coordinates around. In this case, the domain is just the set containing 1 because that's the only x coordinate we see. The range, however, we see a y coordinate of 3, a y coordinate of 4, and a y coordinate of 5. So the range is the set containing 3, 4, 5. Now in this case, we do not have a function. Namely, the x coordinate of 1 has 1, 2, 3 y values associated with it, right? 1's associated with 3, and 1 is associated to 4, and 1 is associated to 5. So that makes it not a function. Let's do a couple of examples that do these answer these same questions using graphs. Here's a graph of a relation. The open circle up here means that that point is not included. And that open circle here is at the point 1, 3. It might be a little small, but that is at the point 1, 3. We want to know domain and we want to know range. Domain is left to right, looking at what the coordinates we see that are satisfied by the x coordinates. What x coordinates we see that are on the graph. Okay, so here we go from -2 all the way over to 5. The -2 is included because that's a filled-in dot. The 5 is included because that's a filled-in dot. And everything else is included for x's except at 1. There's a hole there. So our domain is the interval from -2 to 1, bracket on the -2 because it's included, parenthesis on the 1 because it's not included, and then goes from 1 to 5, parenthesis on the 1, bracket on the 5. Again, for domain, we're not worried about y values at all. We are going left to right and looking at the x values that are represented on the graph. For range we do the reverse. We look at the y values that are on the graph. So we're going to go down from here, where we see a -4 value, and then up to 3, but it's not included, because we're in an open circle again. We don't actually quite hit 3. And there are no holes in between. So in this case, the lowest value is -4. We see it here with a filled-in dot, so that -4 will be included. Goes all the way up to 3. There's a circle at the y equal to 3, so it's not included. So there is our range for this relation. In this case, we notice that the relation is also a function. Over here, vertical lines don't intersect at all. Over here, vertical lines don't intersect at all, but that's okay. All we care about is when it intersects, it only hits it once, and that certainly is the case here. So it really is a function. It passes the vertical line test. Last example. Looking at domain, again, we look left to right. We don't worry about up and down for domain. We only worry about left, right. The leftmost I see is a -1 for an x coordinate, and it certainly looks like it hits -1. the rightmost coordinate goes off to infinity. There isn't a rightmost coordinate, so our domain in this case will be -1 to infinity, and -1 will be included in this case. For the range, a little harder to see since this function is so flat, but notice that the arrow here just indicate, and we don't have anything indicating an asymptote at all, which we'll talk about asymptotes later this semester. But there's nothing indicating there's an asymptote. So this goes off, we assume, to positive infinity for the y's, and likewise this one goes to negative infinity for the y's. So our range will be -infinity to infinity in that case. So our domain, -1 to infinity, -1 is included. Our range is everything. This one is not a function because it does not pass the vertical line test. Over here, for instance, a vertical line intersects 4 times. Over here, it intersects twice. But in any event, we have found vertical lines that do not intersect just exactly once. It's intersecting more than one time. So it does not pass the vertical line test.